Yeah, I've been playing this PC game. It's on Steam. It's called Oasis. I don't know if you ever heard of it. It's like a survival. It's kind of cool actually. And it's actually big, you know. You're kind of like a caveman building your own thing, but you to a point where you build this mobile home, actually, and it becomes like a moving castle. You got to defend it though too, and you can attack other people with too to take their stuff. That's actually kind of cool.
Sounds a little more interesting than I thought.
Yeah,
I've never
so
been a big survival genre guy.
yeah, but this thing you can have your own guild, so you can have other people with their own mobile freaking little house and shit. So you know, the monsters in there is amazing actually.
Huh.
Things they go through. I'm like, holy crap, this is. I know it's a year old or so, but still,
That's why I haven't heard of it.
it's actually a pretty cool game.
In terms of MMOs, I started playing Poke MMO.
Okay.
So apparently they just hit their 10th anniversary. So I guess it's been 10 years I've ignored them. But I guess a bunch of people online managed to make their own Pokemon MMO.
Are you serious?
But it's using assets from all the original games.
Really?
So it has the first 4 gens. And all you have to do is legally back up your own ROMs and install it, and then point to all the ROMs.
Huh.
And yeah, it's literally just all the original Pokemon games as an MMO.
Yeah, my wife plays that Pokemon Go. I installed it on my phone too while she's doing it, so might as well.
I was really big on that for a while, longer than most people were.
So we walked around at night at the Capitol building. There was actually quite a lot of people doing it though.
Oh yeah,
I mean,
I was there too. Don't worry, I got
Oh,
you.
yeah. And it was nice, you know, after dinner, just walk around and, you know, just do it, you know, play some Pokemon. So there were actually quite a lot of people. I was surprised.
And everyone was friendly, and they were all interested in what you got, and
Yeah.
what they got. Yeah,
It's a pretty cool,
I like to bring up that that's about as close as we've gotten to just world peace.
well, it's just that
Really
work
cared.
there too. Actually, people started, they were playing it longer than I have anyways. They were like the Pokemon, that thing, what do they call it? You can group up, what's that called? What do they call it?
Oh, like maybe a guild? No.
No, it's not a guild, like it's like an event, yeah, Pokemon event.
Oh, the event.
Yeah, the events and stuff.
I dropped out around those.
And I was like, oh, okay. I was like, oh man.
Well, I'm gonna wait another couple of minutes because we're at 3. 3's pretty good for last week.
Yeah, I wasn't here last week, had an emergency, so
That's fair.
while throwing a kidney stone, that was
Ooh, those are fun.
you know, it's a hospital for 4 hours. They made him stay an extra 24 because of the surgery, well, that sonar. So they
Are you
blocked it.
freaking kidding me? I had a huge one and they were like, okay, we're gonna give you some morphine. All right, go home. You could probably pass
Well,
it.
because you're younger, you know. I'm about 68.
Oh, that's
so,
fair, yeah.
You know what I mean? So they
4
much you-
days, man. I was
You gotta drink some water, bro. That's what it is, man. That's what I tell them. I'm like, dude, you gotta drink water, man. I was like, you gotta do this.
having been through this a lot, if you start stealing that again, as nasty as it is, put some lemon juice in your water.
Yeah.
That helps a lot.
But just water, period. He hates drinking water, so I have to, you know, my wife, I gotta give him one of those, like, you know, those little squirt bottles, give you flavor. I mean, it's like the best thing I can do. And trying to get him off freaking
Get some.
soda. I'm like, you know, it's like, that's the worst thing.
Get the Propel like
Yeah,
drink mixes.
those are
Yeah.
pretty nice though too.
Yeah, that's what I get.
He doesn't like, that's just water. I'm like, what? You gotta drink water. Crazy.
Yeah, I always do the Propel mixes nowadays because that adds electrolytes to it. So it basically just turns your bottle of water into like a Gatorade.
Yeah. Have you seen that, kind of expensive to, Gatorade? They have a little thing with a cup, you know, you fill up with water. It's the same exact thing. You just mix it into your water and you have Gatorade.
What the hell?
So a little expensive. You have to buy the bottle and then you have to buy the pods or whatever those things. But it's actually, I bought them. They're nice. They're really nice.
I am too cheap for this crap.
So,
I'm
I mean,
very
that's the
sorry.
only thing, but they do get expensive. It's like,
Hey, we're up to 4. I like that number. All right. So, my God, I was so tempted to cancel this class because I'm so tired. But in terms of what we have left for this particular class, I have 30 slides for the entire week. That's what we got. That's what we got. So, of course, today we'll be doing some reviews. I always do. I saw this, I knew it needed to be in my slideshow. Like, yep, okay, cool.
it's,
I have watched people do their laundry when they leave their cameras on.
I thought it's moving.
Had somebody tell me, I'm sorry that I cut out of class early, I didn't realize that it crashed, and I was like, okay, well, that means you weren't looking at it. So, you know, telling on yourself there. But, you know, whatever. So of course, we're gonna be doing some review on everything we covered last time, which is largely just graphing with slope and intercept, finding equations of lines. That's, oh yeah, and inequalities being graphed. So we'll cover a lot of that stuff again, then jump into units of measurement, which really I looked into. I initially, when I started teaching this class, had a lot of tricky problems for this unit. And then I pulled up a lot of practice exams for the high set, and I realized, oh, okay, you're basically just doing one step for all of these problems, maybe two, maybe two. So I have tweaked it to be significantly easier than I used to keep it. So should go easy. Should go easy. So slope intercept form of a line. It's always y equals mx plus b. We use it all the time. It's going to be stuck in your head. So m is always the slope of the line, and then b is giving you the y-intercept. So it's giving you the y part of ordered pair. So if you see down there, you have 0, comma b. That's because whatever that is, that would actually be a point on your graph. Most people aren't anal about that, but there we have it. There's the explanation. Usually I'm okay with saying y-intercept is whatever the heck that number is. So using it, it's really useful. But when it comes to graphing with it, consider the slope as rise over run. So with the slope written as a fraction, each point is rise in the y direction and run in the x direction from each previous point. The b value in the formula gives you the y-intercept, which is your starting point. That is the one point on your graph that you can look at any formula, as long as it's in the right format, you can eyeball it and say, yep, that point's on my graph. Then from there, you use the rise and run and draw your next point. Do it a couple of times until you have a nice kind of template of a line, and draw a line between them. Let's do a bunch of these. By a bunch, I mean 5. 5 ain't bad, right? Right, first one down here. So If y is equal to 4x minus 3, and our instructions are identifying the slope and the y-intercept and graphing. Is it better if I turn on the light? No. No difference. Okay, cool. All right. So we need to identify the slope and the y-intercept. So the slope is always whatever is attached to the x, as long as you have it in your standard form, which is solve for y. Then your slope is always what's on the x. And your y-intercept, I know I said you can write it as an ordered pair, but I like to just say that. If you're on a test and it asks you specifically for the point, you just remember, well, it's on the y-axis, so the x value is 0. And you would just have that as a pair. Okay. All right, so let's graph this. So whenever you graph these, you always start from your y-intercept, which is -3. And then we go rise over run from that point. So our slope is 4. So you want to look at this as if it's a fraction, so that way you can think of rise over run. After you've done enough of these and you see a solid number, you can think, okay, I'm only going over by 1. But until then, it might be a good idea to go ahead and put it as a fraction, put it over a 1. So that means we're going to rise 4 and run 1. Okay, so from that point, put your pen there. 1, 2, 3, 4, run 1, and that's the next point on our graph. You can do a few if you'd like. 1, 2, 3, 4, run 1. Either way, that looks pretty good. And there we are. Not too bad. Not too bad. Let's see what the next one is. 2y. Okay. Copying the next one real quick. Number 2, we have 2y is equal to 1/2 x plus 4. Okay. Well, we can't just say that's the slope and that's y-intercept because we don't have y equals. We have 2y equals. So we have to get rid of that too. Now, normally I would say, oh, just divide everything by 2, right? But that kind of makes a mess right here. Kind of makes a mess. So what I would do is I would, you're safe to divide everything else by 2, but for this one, you'll have to think of it as multiplying by the reciprocal. So instead of dividing by 2, I'm multiplying by a 1/2. Now you could put it over 2 and do the kind of the long form off to the side where you have 1/2 divided by 2. So you decide to flip and multiply the bottom, but that's where it's going to end up. So as long as you recognize, hey, dividing by that number is the same as multiplying by its reciprocal, you're good. You can jump straight to doing that. And that's, I mean, I prefer to jump straight into doing stuff. So, yeah. Okay. So we have y equals, and then we have 1/2 times 1/2. That's 1/4 x. And then plus 4 divided by 2 is 2. So we have 1/4 x plus 2. Okay. So now we have it in our standard form. So that's the slope, that's the y-intercept. Slope is on the x. Y-intercept is 2. And that's enough information for us to go ahead and graph. Now, before I graph, if I look at this as rise over run, you can see, okay, we're going up 1, but over 4. That means my graph is going to be longer, you know, widthwise. So I'm going to have more room in this direction than in this direction, right? Just a good way of looking at it. If you can't remember that, that's fine. That's not gonna kill you. Just one of those things where I like to remember how much work I can skip. I don't need to do -10. I don't need to do -10 over here. I don't need to go up 20 or anything because we're only going to go up a couple, right? So I'm going to start from the y-intercept, 2 in this case, right there. And then we're going to rise 1, run 4. So from here, go up 1, go over 1, 2, 3, 4. We could do it again if you'd like. Otherwise, if you have a ruler handy, just draw a line between them. Since my graphs are always kind of rough, I always do a lot of points. Because I mean, even if my scale's kind of messed up between these numbers, and if my line kind of looks like a zigzag almost between points, technically it's still correct if I graph it according to how my graph looks. So yeah, not too bad. Okay, tab over and copy over number 3. 3. 3x plus 5y is equal to -5. X plus 5y is -5. All right, well, in order to graph this with the slope and the y-intercept, I am going to have to get it into slope-intercept form. So the first thing I'm going to do is think, okay, I need to solve for y equals. All right. So that means I'm going to get rid of the 3x on this side. I get 5y is equal to -3x minus 5. I can divide everything by 5. 5 here, 5 here, 5 here. So I get y is equal to -3/5 x minus 1. Cool. So that's in our slope-intercept form. That means our slope is -3/5. And if you remember, I like to put that negative on top when I do these, just so it keeps that rise over run straight. It could go out front, it could go on the bottom, but just the way I do it, that kind of helps me keep everything straight. If there's one thing I like to do, it's to make sure I don't make a bunch of stupid little mistakes. Which I will admit, I am incredibly tired tonight. So if I make a stupid little mistake and you notice it, like, why did he just do that? Please tell me before I get too far in it. Because I will not notice it until the world blows up. Okay. So this one has a y-intercept of -1 and also a negative slope. So if it has a negative slope, that means that from left to right, it's not going up, it's going to be going down. So when it comes to my graph, everything I really care about is going to be on the bottom, right? So that's pretty much the only place I'm going to care about graphing. All right, so again, we start with the y-intercept. In this case, it's -1. And remember, rise over run. So if I have a negative rise, that means I'm going down. So we're going to go down 3 and over 5. 1, 2, 3, over 1, 2, 3, 4, and 5. I'm not going to do a couple of points on this one. I could pretty easily tell where this guy's going to go. There we go. Not bad, not bad. I might have done 2 points, but kind of have those points spaced out a little too far. That kind of killed that. Okay. Got 2 left. Number 4, copy it over. Number 4, we have 14x minus 7y is equal to 28. Based on the last problem, you can kind of guess what we're going to be doing here. Gonna have to solve that for y equals first. Can't do anything until then. Cool, no problem. Well, got some experience with that. First off, we're just going to subtract over the 14x. I have negative 7y is equal to negative 14x plus 28. And I can divide everything by -7. I'll have y alone here. Negative divided by negative is a positive. 14 divided by 7 is a 2. So we have 2x. Positive divided by a negative is a negative. 28 divided by 7 is 4. Y equals 2x minus 4. Well, that's a lot nicer than our original. I like it, smaller numbers. So our slope is going to be 2, and our y-intercept is going to be a -4. All right. My pen does an automatic dotted line. You can tell there's only enough ink on one side of the ball on this pen. Not my favorite pen, but they work. All right, so we're going to start with our y-intercept. Let's go ahead and get some space for some more points. Now this slope is 2. So that means, you know, if I put it over a 1, I would go up 2 for every 1 I go over. So this one's going to be kind of a slanted diagonal, right? So we probably don't need that much room over here. I'm just going to call it good right there. So we're going to start from -4. And remember, you think of this as being over 1, so we're going to go up 2 and over 1. 1, 2, 1. Okay. 1, 2, 1. 1, 2, 1. And 1, 2, 1. I just have that many points just because, honestly, if I drew the line between 2 of them, it wasn't going to be accurate. And, well, I just kind of felt like I should keep going. Not gonna lie. So a nice hideous line. There we go. Another, next one. Y equals X plus 1. No, I pulled out the tricky ones for this, right? All right, well, what's the slope? We're already in our form, so what's attached to the X?
1.
Yeah, 1. Because it exists, because there is an X there, then you can assume this is 1X. So our slope is just 1. And our y-intercept is also just 1, right? Cool. So I'm going to start at 1. And if our slope is 1, guess what? We're going to go up 1 over 1. Up 1 over 1, up 1 over 1, as many points as you need to. And also go down 1 and back 1, the other direction if you'd like. And 1 back 1. And we just graph 6 points. And there we go. So they're not too bad. Not too bad at all. Does anyone have any questions about graphing with the slope and the intercept? Graphing in general. All right, so let's switch back over here and look at the next stuff. Next up, well, we're still firmly in review territory, and I'll put the word review there. There we go. So finding the equation of a line, and that's always if you're just given some information on the line. So sometimes you need an equation for it, and you have how the line is sloping and maybe a point on that line. Well, you can actually plug that into one of 2 different formulas. If it helps you for the whole test stuff, you could just plug it into y equals mx plus b. You would treat the x and y as variables that you would plug that point into. You would also plug in with the m, and you would solve it for b. And then you would say, okay, my equation is going to have the m and the b, so you put those pieces back onto an equation, and you're good. The other way is using a formula called point slope. The point slope formula is aptly named because you plug in a point and you plug in the slope. Big surprise, I know. So here's that formula. It was never pointed out to me by a teacher. It took me a couple of years to realize that this is effectively just the slope formula where the bottom x's just got multiplied to the other side. Remember, the slope is y2 minus y1 over x2 minus x1.
That's actually wrong.
Don't you start with me. I will turn this college around and drive it straight back home, young lady.
Oh my.
I know. That's how I rock it. Yeah, so point slope formula for a straight line is y minus y1 is equal to mx minus x1. And the y1 and the x1 are the points that you are plugging in. So the other y and the other x kind of just stay a y and an x. And the nice thing about this formula is if you just plug in a point and you plug in a slope and solve it for y, you will have your line done every time. And that's why I kind of like it, kind of useful. Now, if you're given 2 points and you have to find the line between them, then you just find the slope between those 2 points, use that slope and one of your points into this formula. Doesn't matter which one, any point along the line. Couldn't care less which one. It'll work out the same either way. If you feel like doing twice as much work, you can totally check that by yourself. So hey, look, we also have 5 of these. What a surprise. So we're going to find equations of these lines. So the first one gives us 2 points, and we need to find an equation for it. Yep. So we have the point 2,5 and 3,6. Well, remember your slope formula. That's y2 minus y1 over x2 minus x1. Okay, difference between the y's, that's the rise between 2 points. Difference between the run, that's the run between 2 points. Okay. So all this is really telling us is we do 1 point and subtract the other point. Okay, well, in our case, I can do y minus y over x minus x. I end up with 6 minus 5, 1, 3 minus 2, 1. Guess what our slope is? 1. Cool. So I need a formula for this. So we will use our point slope formula. There's a good screen to show that if I took this and I multiplied it over to this side onto the m, it would look exactly like this. So it's really the same formula. Kind of cheap, but it works. All right. So we just need to pick one of these points, plug it into this guy with this slope. Well, let's go with this guy. This guy has slightly smaller numbers, right? So we'll do y minus 5 is equal to m. In our case, it's just 1. X minus the x value on that point is 2. So we have y minus 5 is equal to 1 times x minus 2. You don't really need that 1 times a set of parentheses, right? Normally, whatever's here, you would have to distribute through. In this case, we can actually just drop those parentheses. And then add the 5 over. So we would have y is equal to x plus 3. And that would be our formula. Man, my y's just get jankier as that problem goes down, and then they full on disconnect at the bottom. Like a weird little smiley thing. Okay, not too bad. Let's do a bunch more. Love doing a bunch more. Okay, so the next one tells us that we have a slope of -3, and it passes through the point 6, 1. Okay, so that one is just handed to us for that formula, right? We're going to do y minus our y value is equal to m x minus our x value. So we pretty much have our equation. We just got to clean it up, right? We're going to take that -3 and distribute it through. So I have y minus 1 is equal to -3x -3 times a -6 is a positive 18. And then we can add the 1 to both sides. So I have y is equal to -3x plus 19. Good one. All right. Cool. Let's do more. So the next one says we have a slope 5. And it passes through the y-axis at 3. Slope is 5 and it passes through the y-axis at 3. Well, what does that mean? Going through the y-axis, that's our y-intercept. This is probably the easiest problem we have all night. Because we can just throw it into our y equals mx plus b. Y equals 5x plus 3. Cool, we're done. That's the problem. Good problem. I like it. Neat, it's precise. But that's an example of sometimes they will word things funky. And you have to be able to decipher that. So seeing that it passes through the y-axis, you should think that gives me a point on the graph. What point is that? In this case, that happens to be our y-intercept, so we are good. Now, number 4 is a little bit trickier. It says that it crosses the x-axis at 4 and the y-axis at 5. Now, based on that last problem, we can already tell that our b, our y-intercept, is 5, right? You can already tell that. However, what the heck am I going to do for my slope, right? Well, what I would do on this particular problem is look at this and say, okay, if it's crossing both axes, that's telling you there's a point and there's a point. So let's get it into our point forms. Hello.
Hi.
Would you like to interrupt?
Yes, may I?
Yeah, totally. Let's do
You are
it.
doing it.
Yeah, just
So-
roll with it.
I already talked to Taya. We're good. Is there anyone online right now?
There are 4 people online.
All right. So Brian already heard my spiel yesterday. And we have, who else? Tobias?
Tobias, Sandra, and Kelly.
Let's see. So let me make a note of Sandra. And Sandra heard my spiel last night too. Kelly has not,
Oh, snap.
and Tobias has not.
I mean, I don't know what your spiel is either, so I haven't heard it.
Good one. It's a good one.
Okay, I'm excited.
So this is in reference to, this being the last week of class. So you're done this week for this session. You'll have 1 week break and then the next session starts a week later, October 10th. And so, I have some class admission forms to share with you. All the information is still the same Zoom link, same teacher, same location, all of that is the same. It's just, this is just a way to prove that you are enrolled in the class for the next session that starts October 10th. It's a really short turnaround this time around. There is, so for you, Tobias, online, I'm gonna go ahead and email you along with, Brian and Sandra still. I'm gonna email you your class admission form, so you have that information, but just know you're taking a week break and then you're coming back to class. If you guys would like to discuss anything with me as far as how things are going in class, if you need additional support or any of that type of stuff, please feel free to email me back, and let me know how that's going. There's also a new class, so everyone is aware. This class is called the HSE Hustle. HSE Hustle class. It's a week-long class. And it's a pretty intense class. It's Monday through Thursday.
So wait a minute, it's every day for a week? So every day you're hustling?
You're hustling every day.
Oh, God, I
You know
hate
that
myself.
song, that's very fitting. So, this class, you have to be able to qualify to get into the class. You have to have an NRS level of 5 or 6, to be able to do this class. We have a class going in October. There will be another class available in December. It's a 4-day class from 5:30 to 9 o'clock at night. And then on the 5th day, Friday, you will take the official exam. Okay, so that's why it's called Hustle, HSE Hustle, because it's a pretty extreme class. So for some of you who are continuing with this course this time around, we will talk to you at the end of next class. At the end of next class, it will be a one-on-one conversation, not a class environment conversation. And based on how you do on your assessment, on your post-assessment, and how things are going in class, will determine if you are eligible for the hustle, for the HSE Hustle class. Now, for now, I think, Kelly, are you online? Kelly, can you hear me?
Yeah, I'm here.
Awesome. So Kelly, I know that it might sound a little crazy and scary to take this, but I really think you would be excellent at taking this class. Why?
Oh,
No.
yeah.
Only
I
because-
mean, I don't know. I'm not too sure. I kind of want to take like another, to see where I'm at, like another test to see where I'm at now. I know
Okay.
I'm working with my tutor too, so I just kind of want to see where I'm at before I
Okay.
like make that jump. But I do have other things I wanted to talk to you about too. Is this Elizabeth, right?
Yes, it is. Yes.
Yeah.
Over
So
there. Pointed here, so.
Oh, okay, here, let me get,
maybe, yeah, maybe I can give you a call tomorrow.
yes, please do. Please do. I will
Okay.
be here tomorrow from 9 to possibly a little after 6.
Okay,
So, yeah.
perfect. I definitely will.
We'll discuss it. So maybe you would want to try the hustle class in December. Maybe that's a thought.
I mean, yeah,
But again, the
yeah.
purpose of the class, it is extreme, it's intense. And then when you take the official test on Friday, it's just, it's not a guarantee you're gonna pass every single subject, and that's okay. But the purpose is to try to get some of those off your plate, that way you don't
Yeah.
have to worry about those anymore, and then you can just focus on the ones that you didn't pass, if that's the case, or you might pass them all. We just never know.
I'm not feeling too confident, but that sounds good. Yeah, I mean, I don't know. Maybe I could just call you and we could discuss some things and
Absolutely.
figure it out from there.
Okay, sounds good.
Yeah.
And I
Okay,
just
cool. Thank you.
share that with the whole class too, just so maybe that's a goal that the other students would like to try to do later on. In order to take an assessment, you need to accumulate at least 60 hours of instruction. So Kelly, I'll talk to you to see where your hours are when you call me tomorrow.
Okay.
But for everyone else, same thing. So the hours that you've been spending in class this time around, and along with all the other hours you'll be spending in class for the next session, all of that accumulates. So once you get to 60 hours, we'll give you another post-assessment and we'll see where you're at based on those results. Okay.
You're close to essential education.
Yeah, do essential education. Yeah, do some work there, because all those hours count there too. And it's about you practicing. That's what it's really about. Okay, so does anyone have questions? Anyone online? No?
Always gotta give it a second. Takes a while for the mute button to be found.
That's true, that's true. And not all
I
at
hate
once,
finding it.
please.
Yeah, they're not gonna talk.
I don't want to get overwhelmed.
Last year, this isn't really like, I don't know, but I used to do the online, did that count too from last year? Did it kind of get like erased in a way?
Ah, good question. So it's every fiscal year.
Yes.
And if you've had more than 90 days without instruction, you are no longer a current student. You become inactive.
All my work went away.
Yes. Yes.
That's called
unfortunately.
practice.
But it's not, yeah, it's practice.
Yeah, it was good. It was.
You recorded it in your brain, so that's good.
It's called practice.
Yeah.
And one nice thing about this 2 6-week thing for this fall is that normally the 8-week classes, I can't get through as much. But this time, by the end of the next class, I should be able to cover every single topic that's on the high set for math.
Cool. That's excellent.
Yeah, they're gonna suck. They're gonna particularly suck, but you know.
We love math though, right? We gotta tell ourselves that.
Gotta have fun.
Gotta have fun, yeah. All right,
But if you're a
guys.
sarcastic guy teaching you, it's fine.
So if you guys have questions, just let me know. You know where to find us, find me. And for you, sir, I'm gonna give you your class submission form now. Thank you, guys.
Cool, we were doing that.
You did it wrong.
Don't be. That's it. Okay, for the record, that is entirely a possibility tonight. Because I slept for like 4 hours last night. And I had to bike across town by 5:30 to get to work this morning. So
We'll see.
I don't like having a full 8-hour shift before 2 in the afternoon, but it happened. And then I came in here and I tutored in this room for about 3 hours,
Yeah.
2.5, 3 hours after that. Went home, got a sandwich, changed out of my scrubs, came here. This thing doesn't look quite as wrinkled, but I literally pulled this out of a pile. This shirt came out of a pile because I remembered to do my laundry at the last minute last night, so everything I own right now is in a pile. And that is not getting folded tonight either. It's probably getting rewashed tomorrow evening because, well, I just. You can actually make a decent like wrinkle release spray if you put a little fabric softener into a bottle with water.
I say it too.
Bye, guys.
Sorry.
Goodbye. I'll miss you.
Bye.
Give me a lie. I'm not capable of lying. I'm really bad at it. I have no memory. If I lie, I get caught immediately. It's a terrible plan. All right. So let's see. Yeah, math. Okay, cool. So we are trying to find an equation of a line that crosses the x-axis at 4 and the y-axis at 5. I don't much care about having a perfect graph here. Clearly, but that means that we have this point and this point, right? So judging by that information, it seems to be going down, so our slope is going to end up negative. So if we do some work and we end up with a positive slope, we know we're wrong. Getting a visual is always helpful. Second of all, we can put these down as ordered pairs. We can put them down as points. So this guy up here, our y-intercept, that's when x is 0, and we have y as 5. And then over here, our x-intercept crosses the x-axis. That's when x is 4, and it's going nowhere height-wise, so we have a 0 there. Okay, so we have 2 points. If we have 2 points, we can get a slope between them. We get a slope between them, then we can plug them in and get our line. Okay. So our slope is going to be the difference in y's over the difference in x's. I'm going to be cheap about it. This minus that. over this minus that. So I end up with 5 over a -4. Or a -5/4, however you want to look at it. But we did end up with a negative slope, so we probably didn't make a horrible mistake because this thing is sloping downwards. Now we need a line. Okay. Well, we're going to plug that into our usual formula, which I will rewrite. Okay. So we just need to pick a point to plug in. Doesn't matter which, don't care which. Don't care at all. Now, maybe I care a little bit. Maybe I care a little bit because I know that this M is going to distribute in. And if that M distributes in and hits this weird looking fraction, I probably want that to be really easy, right? So I'm thinking the one where X is 0 is going to make our lives a lot easier to plug in. I tried to draw a star, I screwed it up, I kind of saved it. Whatever, good enough. So yeah, we're going to plug in the one with the 0 for the X because that distribution will be a lot easier that way. So we're going to have y minus the y value, 5, is equal to our slope. I'm just going to write it this way, -5/4. X minus, well, our X value is 0. So that makes the distribution really easy because it just multiplies onto the X. Well, that looks really easy to solve for y. Add the 5 over. We have y is equal to -5/4 x plus 5. Do we like it? Do we hate it? Are we feeling okay? Is that a meh? Okay, I'll allow it. I'll take meh. Meh is better than good. Which, to be fair, when I'm talking to most women, that's usually the response. Self-deprecation. Okay, and our next point, our next problem is slope is 3. And it contains the point -400 and 500. And asks for a graph. You might look at that and say, am I graphing -400 and 500? Probably not, right? So we have our point and we have a slope, which means we're going to plug it into our usual formula. Now I'm subtracting this negative. That's going to end up changing to a positive. And we're going to distribute that. We have 3x plus 1200. I'm going to add 500 to both sides. So we have y is equal to 3x plus 1700. How the hell am I going to graph that? I don't want to check off 1700. Well, sometimes you will run into graphs. Usually usually it's useful in like statistics, like real world applications. Like sometimes you'll have, you'll see graphs and populations are in tens of thousands or millions or whatever. And they'll kind of go up from there. But what happens when all your points are going to be pretty close together? And then you have this giant jump. Well, it's cheap, but it works. Sometimes you just kind of have this little squiggle and then say that's 1700. Totally cheap, but it works. Then you'd have 1701, 17.2, 17.3, 17.4, 17.5. So that squiggle is just going to represent that we don't really care about all the values below that. We're just gonna kind of call it good there. Which is fair because our y-intercept is 1700, which means that's our first point. And our slope is 3, so we go up 3 and over 1, right? 1, 2, 3 over 1. Oh, and if you have this crazy scale going, probably a good idea to actually write some points here. That way you can tell that the scale on the X is in ones. The scale on the Y's is also in ones, but it's also skipping the first 1700 values. Up 3 over 1. And we have our graph. This is the sort of problem where you might see, usually you won't graph these, but these are the types of things where you might see it as, say, this might graph how many bacteria are hanging out on your hand at any given time. Something like that.
How did the 500 become a negative 500 when you have it written at negative 400 to 500 on a
Where we
above? No. If you go up the M3, there you go. You have a negative 400, negative, then positive 500, right?
Oh, why is this? a
Yeah.
different time? Because normally you are subtracting that value and we are subtracting a negative 400. So if we're subtracting a negative,
Oh,
it turns into a positive. But yeah, that's it. Any questions on finding equations of lines? Are we excited about finding equations of lines?
So excited.
Yeah, you just can't hide it, right?
No,
Okay, cool. Normally, this is the time of the class where I say, let's do new stuff. But we got one more thing. One more review thing. I love review. Don't you guys love review? I love review because chances are I showed you once and it didn't stick. So I show you twice, you got a better shot. So, inequalities on a coordinate plane. Now, the linear inequalities are not as bad as you would think. You basically just have a line that instead of an equal sign will have a greater than or a less than or something with a bar under it to give you an or equal to. But you always graph it as a regular line at first, just like the last several that we did. After that, you have to figure out, well, which side of the line is going to be shaded. So at that point, you pick a point on either side of the line and plug it into your equation. If you get something that is correct, that's something that makes sense, something that is true, then that means the side that you picked that point from, everything on that side is going to be correct, so you would shade that side. If you get something that was false, something that was wrong, then you would say, okay, that entire side is wrong, which makes the other side right. Let's do a couple. Maybe emphasis on a couple. I'm tired. All right. So solve and graph on a coordinate plane. I think at the very least, we're gonna do 1 and 2. Okay. So when it says solve, that's basically asking for the shaded part of the graph, because we have 2 variables, there's no way to just get an answer, right? So one thing to keep in mind is that if you have a greater than or a less than, but not a greater than or equal to, or a less than or equal to, so you don't have that bar underneath, this guy right here is going to mean that we are going to use a dotted line. That will represent that it doesn't include everything along the line. Because if there was an equal sign here, anything that would make, any point that would make this equation true would normally be along the line. But in this case, we have an inequality. We're saying everything has to be greater than 10. So we are picking a side of the line. Now, if it said or equal to, then it would be along that line and we would be good. But in this case, we have a dotted line. Okay, so our main thing is that just that we need to graph this for now. Let's worry about graphing. So again, I like to graph with slope and intercept. So what I'm going to do is I'm going to solve this for y. So we're going to have 5y greater than, oh yeah, by the way, I'm subtracting 2x. Ha. If I skip steps or ramble for too long, just rein me in. We have 5y is greater than negative 2x plus 10. Then I'm going to divide off the 5 on everything. And I have y is greater than negative 2/5 x plus 2. Cool. So I really just got to graph that, right? So our y-intercept is 2. And our slope is negative 2/5. So from that 2, we're going to go down 2 and over 5. Now, I'm not going to go any further in terms of graphing it. I'm just going to put a nice dotted line between these points. Now we're worried about which side of this that we shade. So you pick a point on either side, doesn't matter which. And again, like I said last time, if I can get away with it, I like plugging in 0, 0 because that makes our math really easy, right? So what I usually do, I'll plug it into either what we've graphed or our original, whichever one makes it easier. I'm thinking plugging a 0 and a 0 in here would be a lot easier. So 2 times nothing plus 5 times nothing is greater than 10. So is 0 greater than 10? No. It's a false statement. And if that's the case, that means everything over here is going to spit out a wrong equation. It's going to give us a wrong statement. So if everything over here is wrong, that means everything over here is correct. You would go ahead and shade that. Or shade with a pen, it's awkward. Now, if you're unsure about that, if you're thrown off and you're like, what did that weird rambling guy talk about when he did this? And you get something like that and you're like, I don't know if that's enough to to immediately assume that the other side is correct, you can always just pick another point on that side of the line. I guarantee you it would work out. Like say I picked x is 0 and y is 5. So if I plugged in 0 for x, that's gone. Plugged in 5 for y, cool, I get 25. Is that greater than 10? Yes. So every single thing on this side of the line is going to make this equation true. How do we like these? Are we feeling okay? Are we horrified? Let's do another. Maybe you enjoy them. Maybe you're like, if I keep quiet, this guy's gonna keep doing these. This is incredibly entertaining and I'm excited and enthralled by every single step. Okay, so the next one, we have y is less than or equal to 1/4 x minus 1. Now, nice thing on this one, already in our form, right? So we can go ahead and just graph this. Now it starts at a -1, and it's going up 1 and over 4. So this guy is not going to have a whole lot in the negatives, but it's going to have a lot in the positive x, right? I don't really know if I need all that, but it's there now. So, hey, whatever. Okay, so we're going to start from our y-intercept, the -1. Then we're going to go up 1 over 4. 1 over 1, 2, 3, 4. There's the second point. Did all this, might as well keep going. Let's do one more point. Up 1 over 4. There we go. Now, since this one has a bar underneath, that means that this one is going to be a solid line. So we can just go ahead and draw a line between those two, or those 3 points. But we're not done because we need to shade one of the sides. Because we got the or equal to part covered, but we need the less than part. So again, we pick any point. Let's not go with something on 0, 0. Let's pick something that's a little bit tougher. How about, since I'm multiplying that x by 1/4, how about the point 4 and -1? So we're going to test that point right there. So plug it all in. We have -1 is less than or equal to 1/4 of 4 minus 1. We have -1 is less than or equal to 1 minus 1. -1 is less than or equal to 0. So is -1 less than 0? Yes. That is a true statement. If that's a true statement, that's the side that we're going to go ahead and shade. So how do we feel about these? Are we good? Do we need to see more? Or do we need to move on? Anybody need to see more? Nobody is flailing. So I assume we can go ahead and skip the other examples and move on to new stuff. We like new stuff. The new stuff, units of measurement. So this whole section is largely just contingent on being able to convert from one unit to another unit. So for instance, like cups to gallons and stuff like that. This is generally the section where you're like, wow, why the hell don't we use metric for everything? The answer is I don't know. I mean, most of the science world uses metric. Drug dealers use metric. Nobody says a pound of coke. They get a kilo of coke. I don't know the difference between a kilo and a pound. We could work it out. That terrible? That terrible joke to make on? I don't care. All right. So if you remember when we were doing some of the ratio stuff and we had unit rates. Unit rates was, you know, like miles per hour. So however many miles you were going per 1 hour. This whole section is completely stuck on that concept. In order to convert from one unit to another unit, you're usually going to be using a unit rate between one unit and another unit. So in terms of units of measurement, there are actually different systems of measurement. One of them, as I said, is metric. The other one is kind of fascinating because I went hunting and like nobody seems to agree on the name. So sometimes it's referred to as the American system. Sometimes it's US customary system. Sometimes they just call it standard system, which I feel like is kind of cheap because, you know, not really the standard when we have two. So before we convert between our units, we have to be at least a little bit familiar with what we have. Totally have these in the wrong order. There we go. Okay. So I got a slide for each of the kind of sections of the unit systems we have. So generally it's length, weight, and capacity. In metric, there isn't a weight, it's mass. It's kind of different. Kind of like when you're like, oh wow, you weigh about a sixth of what you do on Earth when you're on the moon. Well, your mass would be the same. There doesn't seem to be a direct conversion between the two. It's kind of weird. In order to convert between the two, they actually are contingent on gravity. So all of the formulas only work on the planet Earth. Everything else, well, you gotta get a little more tricky. So length we're all pretty familiar with, except for maybe miles. A foot is 12 inches. A yard is 3 feet, which would translate to 36 inches. And a mile is the most annoying one to remember, but I always remember it because I've had to write this down probably into the 4 digits, probably at least 1,000 times. 5,280 feet in a mile. That one's particularly useful for converting. Run into it a lot. One thing I do want to cover real quick. I have this in last Google Drive folder, but there's a similar one for GED if you're taking GED, but for the high set test, these are the formulas you are given. So you don't have to commit a lot of this to memory. I believe something similar is given to you when you take the GED. If you're taking it online, I'm not quite sure how the information is given to you, but I know it's still given. So effectively, what you're going for here on converting units tonight, you're not going to go for memorization. you're going for the method. You want to be able to understand how to convert between the units, because you will be given all of the general conversions you're going to need. Okay. And all of this stuff over here on the left, well, we're going to be covering that in the next class. That next class isn't Thursday, next class is in next 6-week period of time. I actually think I'm starting off on geometry in that class. It'll be fun. Everyone loves
Thursday, is the last class of this, right?
for this one, yeah.
Take a week
So
off.
Thursday, take a week off, which I'm fine with because my schedule is all over the place next week. I looked at it and I'm like, wait a minute, I work Sunday and then Wednesday and then Friday and Saturday. Like all over the place, my
Oh,
schedule.
you don't have a set schedule over there?
No, no set schedule. I think they want to set it up as a set schedule, but it's really rough to do so, especially given that people put in for PTO a lot. Lots of different stuff. But I'm really regretting not putting in for PTO next week because it would have been really cool to just be like, yay, vacation. Whatever. Okay, so then we have some units of weight. Not a whole lot of those. So 1 pound is 16 ounces and 1 ton is 2,000 pounds. And throughout the problems, I will be switching back over to the slides so we can refer to these, because a lot of these, I don't have them stuck in my head. I definitely don't have them stuck in my head. And capacity, so largely volume. This is, usually dealing with fluids. So 1 cup is 8 ounces, fluid ounces in this case. Because, we have weight ounces, we have fluid ounces, because English is weird. English is the worst language on the planet. It's terrible. I feel like communally, we all need to just work out a new language, build upon it, make a structure that isn't stupid, and then just everyone convert to it and just call it good.
Yeah, it's called English.
English is god awful.
Yeah, but around the world, English.
Yeah, but it does, there's exceptions to literally every rule.
Oh, yeah. Oh, yeah.
I before E, except after C, except for literally half of the time.
Well, that's not it. Then you have the slang term that will kill you.
Yeah.
You have tear and tier. That's where like most of my family was French. Can't get it to like.
I
what I mean?
always
So-
refer to the actor's name, Sean Bean. I always refer to his name when I talk about English sucking, because EAN and EAN, and you pronounce both of them completely freaking differently.
And
Sometimes
that's the whole point of that slang English.
I just like calling him Scene Bean. It's okay, it's not gonna kill him, except for every movie he ever dies in. Most movies you see Sean Bean in, he died. All right. So a cup was 8 fluid ounces, a pint is 2 cups, a quart is 2 pints, 1 gallon is 4 quarts. This one is my least favorite of all of them. I hate remembering these. I will never remember these for the rest of my life. This, like, I could do a gallon is 4 quarts because it's quarters. That was easy. But pints and cups and fluid ounces, nah, it ain't gonna stick. Okay, so those are all the units in the American system. But we kind of need to know how to convert stuff, right? So I went with a nice example of converting an amount of minutes to seconds. So what you end up doing is you take advantage of the rule that we can multiply anything by 1, which is much as what we do when we get a common denominator between fractions. So you end up multiplying by unit rates all the way across, like just single units. So if you look at how I have this set up, I have this set up to convert from 4 minutes into seconds. So I usually put what it is I'm converting over a 1, unless I have multiple units like minutes per foot for some weird thing. And then I'm going to multiply it by something to convert. So you always convert with something that the top and bottom are equal to each other, but they're in different units. So a minute is 60 seconds. So it's technically multiplying by 1, but you're kind of reframing it by doing that. Now, one thing that I wasn't able to show on this slide that you will be seeing a lot is that the units cancel the exact same way that numbers do. And out of everything I failed at in engineering physics, that is the one thing that stuck. I had a professor that made us, doesn't matter what we were doing, every step of every problem we ever did had to have all of the units attached. So as you can imagine, that was a lot of writing. But it made it more understandable when we got to the end and we could see exactly which units we had. So if you look at what we have minutes on top on the left and minutes on the bottom on the right. Well, they cancel just like when we're reducing fractions, we're multiplying together. The minutes on the top left is going to cancel with the minutes on the bottom right. And then your only unit left is going to be seconds. That means that whatever you have from this is going to be in seconds. You can absolutely get some really weird units this way. Case in point, acceleration is actually meters per second per second. So it's meters per second squared. It's weird. So here's an example, not the prettiest example, but I have this example as converting yards to miles. So converting 7,920 yards into miles. So in this case, we are given a conversion unit. We have that 1,760 yards is 1 mile. So you set up your original unit over 1 to make multiplication easier. Then use the measurement above to multiply and change our units. So in this case, if I have 7,290 yards over 1, I would multiply that by something with yards in the bottom, so the yards would cancel. And we would be left with miles. You multiply across on top and bottom, you get a fraction that usually looks weird. Divide them, get a decimal, call it good. Embrace the decimals. It'll make a little bit more sense when we're actually working these guys out. Probably going to be deleting a bunch of these when we get to the metrics, just because I got decaliters in some of those problems. You're not going to use those. Okay. So for number 1, we're just going to convert 25 feet into yards. I know my explanation slides were weird, but this is a lot easier in practice. So we're going to go ahead and write 25 feet and put it over a 1, because everything we multiply by is a fraction, so we might as well have this in a fraction just to make it look nicer and our work to be easy. Now, if I'm converting that into yards, well, I know how many feet are in a yard, right? 3 feet to a yard. Well, sometimes, you know, maybe not in this particular instance, but sometimes when you're doing these, you're like, wait a minute, do I divide by this number or do I multiply by this number? That's a pretty common thing, and I do that constantly. And it's like, let's find a way around that. So what I like to do, this is my personal method, I like to look at this and say, okay, well, where are my units going to go first? I'm not going to worry about what I'm plugging in number-wise. I'm going to worry about the units. So I have feet to yards. Well, I know I have a conversion unit for feet to yards, right? So if I'm trying to cancel feet, then our unit for feet is going to have to be down here. That way it'll cancel out. Top and bottom cancels out, then you're good. So that would leave top for yards. Now at this point, you would just plug in what makes that true. How many yards is how many feet? Well, 1 yard is 3 feet, right? And there we go. So what we end up doing is effectively we end up dividing by 3, but this particular method will scale up to as difficult of a problem as you need to make. I have done these problems where it's converting from like an aquarium that has inches by inches by inches, and converting that into liters of fluid for volume. And you end up with like 15 fractions multiplying across just to bounce around between those. But you always end up with the right answer because you are keeping track of your units. So in this case, our feet cancel out. I always like to draw that, make sure you do it because that'll make your life easier. So we cancel out the units that are canceling, and you multiply across on top and you multiply across on bottom. Now, yes, you might not necessarily need to write that. You might be able to clearly see, hey, this is 25 divided by 3 and punch it in over here. But I like to show this step because, again, that concept will scale up. If I have like 40 different fractions multiplying together, that sounds like a mess. I'm going to multiply across on top, then I'm going to multiply across on bottom, then I'm going to divide the two. So that will work every time. Now, in this case, we have 25/3 for yards. And most of these, I recommend just going ahead and getting a decimal. So punch it in the calculator, we get 8.33, the 3 repeats, yards. Okay, so not too bad. The next one is 5790 yards to miles. Okay. Now, I could use that conversion that I had in the slide where it was yards to miles directly. But in this case, I'm not going to because there, oh, there it is. All right, I still have it up. If you look at this formula sheet, we don't have anything going directly from yards to miles. In fact, you really don't ever do directly from yards to miles. And if you do, you just take another step. So that's how we're going to do it, is we're going to get we're going to go from yards to miles. Well, let's go back to our slide for American units of length. So we need to go from yards to miles. So we have to find a unit that those pieces would have in common. Well, miles we can convert to feet. Well, if I can convert from feet to miles and back, and I can convert from yards to feet and back, well, I could maybe go from yards to feet and then from feet to miles. So now we have a two-step problem, but we'll get there. So it might help to actually kind of have like a little path written out when you make that strategy, that we're going from yards to feet to miles. You don't need it, but I feel like that could come in handy just to keep things straight. It's just useful, right? So, okay, let's start it off. We have 5,790 yards. I'm gonna go ahead and put that over 1 like I always do. And we're gonna go from yards to feet. Well, we just went from feet to yards. Am I gonna write this exactly the same? No. If I wrote 1 yard over 3 feet right here, and I multiplied across, I would have the units yards squared per foot, which sounds weird, and I don't like it. So we need to make sure that what we're doing by converting from yards to feet is we're going to cancel out our units of yards. So it's on top here. It's gonna have to be on bottom here, which leaves feet to go on top. And then we fill in what makes this true. 1 yard, 3 feet. So you can see, comparing the two, that sometimes you'll just flip them upside down and it just works out really nicely, because 3 feet is 1 yard. So I'm multiplying by 1. Now the yards unit will cancel out, and we have some number, you know, like 16, 17,000, 16 and a half, something like that. But now we're in feet. I could multiply that through and then say, okay, that many feet, and convert that to miles. But what I like to do is we just keep it going. We're going to multiply by another fraction, and we're in feet, but we can go from feet to miles, right? Now, if feet's on top, then to cancel feet, I'm going to have it on bottom. And that means that miles is going to have to be on top. Then you plug in the numbers that makes this true. How many miles to how many feet? 1 mile is 5,280 feet. Well, now my units of feet cancel. What units do I have left? Miles. That means that whatever we get out of this jumble of fractions multiplied together is in miles. That's our goal, so that's our answer, right? So all we got to do is solve it at this point. So multiply across on top, and when you do these types of problems, you're going to have a lot of ones hanging out. You can just skip those because anything times 1 is itself. So on top, we're going to have 5790 times 3. So I have 17,370 over the 5,280. And our units are miles. Now we're going to take that, we're going to divide it, get a decimal, and call it good. So it's approximately 3.2898, because it just kind of keeps going. So 5,790 yards is about 3.2898 miles. Any questions on these ones so far? We're happy with them. We like them. We love them. So the next one is 313 tons per pounds. Okay. Well, let's refresh what we got, tons and pounds. Well, 1 ton is 2,000 pounds. We can certainly make use of that. I'm gonna write that down real quick. 1 ton, 2,000 pounds. Okay. Well, this is gonna go real quick, right? Because we have something that goes directly from what we're starting with. T looks like an F. I have fonts. How many Fonzies go into this? Tried to fix the T, just got more and more horrible, unhappy. All right. So then we're going to multiply by a conversion to get to pounds. So to cancel tons, we'd have tons down here and pounds up here. Then you can fill in numbers. 1 ton, 2,000 pounds. Tons cancel. And if it's all over 1, you kind of skip right in that, right? So 313 times 2,000, well, 313 times 2 is 626 with 3 zeros. And that's in pounds. How do we like it? We like it, we love it, we're excited. Do you have a question?
No, yeah, I just did it the other way really simply, so, but using that formula works. So.
No, yeah, you can absolutely, if you know that you're just gonna multiply it by 2,000, you can write 2,000, whatever. If it's something easy, you don't have to stick directly to this stringent method. If you have a nicer way of doing any of these problems, go for it. Not a strict thing. You're just doing the math as you see that works. Now this works probably best with, you know, the trickier problems. And actually, as you get higher up, this method is actually usually referred to as dimensional analysis. But I find it works just as well for teaching basic conversions. So why would I have multiple methods of doing the same thing if one of them is quick and easy? So the next one is going to be 5 tons 2 ounces. 5 tons 2 ounces. Let's go back and look at our stuff here. Okay. So we have that 1 ton is 2,000 pounds still, but also 1 pound is 16 ounces. So this is one you could get away with just multiplying straight across. But I'm going to do it the usual method anyway. So I have 5 tons. I'm going to convert that from tons to pounds and then pounds to ounces. So from tons to pounds, we'd have 2,000 pounds is 1 ton. Tons cancel. Then you can multiply that by pounds to ounces. 1 pound is 16 ounces. Cancels, cancels. We are left in ounces. Let's see, 5 times 2 is 10, times 16 is 160, with 3 more zeros. And we are in ounces. I am gonna move that unit over a little bit because that just looks like another 0, doesn't it? In fact, I'm just gonna write out ounces. There we go. Can't mistake that. So that works. 100% that works. Do I have more? Pretty sure I have more. So number 5 is 3 miles to inches. So we do the same thing, 3 miles over 1. Now multiply that by, well, if I'm going from miles to inches, I'm probably gonna have to go to feet first. Honestly, that's the only thing we really have is miles to feet. And then from feet to inches. We'll have miles, feet. 1 mile, 5280 feet. Miles cancel. And then we can go feet to inches. So 1 foot, 12 inches. Totally can't multiply that in my head. You can tell I like multiplying stuff in my head. I'm not as great at it as I'd like to be. I've tutored people that could do mental math that just blows me away. I'm like, how do you even learn to do that? Really, how? Because I went looking, trying to figure it out. And I'm like, oh, not really resources on quick mental math. We have 190,080 inches. So if you're ever really mad at your kid, you can hand them a ruler and tell him to start counting as he goes down the road, and don't stop until you count 190,080 inches. One
The
thing
equation that for hours.
Huh?
Count 190,000.
I mean,
2 hours. Well,
we
yeah.
could estimate it if we figure out about how long it would take us. If I went across this table and I started counting that, we could estimate it. It would work. It's like when I worked at GameStop and there would be kids begging for stuff and the parents eventually cave, and I'm like, well, you could always make them work it off because child labor doesn't have a minimum wage. So I always told them to hand them a ruler and some nail clippers and tell them to mow the lawn. Reasonably, I have no children. So far, no one has been dumb enough to procreate with them. Okay. Number 6 is asking for 12 gallons to quarts. And as I've said, that's my least favorite. Let's go back over here and devise a strategy. Well, gallons to quarts is the only one I can actually do off the top of my head, right? Because 1 gallon is 4 quarts. Makes sense. A quart is literally a quarter of a gallon. Yeah. So we can do this one pretty quick, actually. We can do 12 gallons over 1. We're going to multiply that by going from gallons to quarts. Gallons on the bottom, so we can cancel it. 4 quarts in 1 gallon. Cancel the gallon unit. We just have quarts left, so 12 times 4 is 48 quarts. Not too bad. Not too bad. And number 7. We have 3 pints to fluid ounces. Okay, well, let's again devise a strategy. So 1 pint is 2 cups. And 1 cup is 8 fluid ounces. So if I go from pints to cups and then cups to fluid ounces, then I'm good. All right. We have 3 pints. Gonna put that over a 1. We're gonna multiply that by going from pints to cups. Okay. So 1 pint, 2 cups. So the pints cancel. Then we're going to go from cups to fluid ounces. So cup, fluid ounces. 1 cup and 8 fluid ounces. So the cups cancel. We multiply across. 3 times 2 is 6. 6 times 8, 48 fluid ounces. Okay, so that was the last one I have for the American unit. And you'll notice that for the most part, we ended up having everything over 1. Why did I really go over this if I'm just gonna have everything over 1 every time? Well, what ended up happening is if you look at all the ones we did, just about everything we did was going from a large unit to a smaller unit. And we had direct conversions for those, right? Each one went a step down. Now that can be contrasted by, say, that those first couple where we were playing around with it. This one, feet to yards, went up. And if it went up, that means that we suddenly were going to have bigger numbers in the denominator instead of the numerator. Or like number 2 here, when we had to go to a smaller unit and then back to a bigger unit. So you end up with things kind of flipped sometimes. So notice that if it goes to a smaller unit, you end up with 1s across on the bottom, right? But if you go to a bigger unit, you end up with 1s on top. So this particular method, even though we ended up with a whole lot of 1 on the bottom, didn't seem to be too useful. But depending on the problem, depending on the strategy you gotta use to get to to your answer. You know, doing it this way could save a lot of headaches. Okay. So. The next one we have is time. Now, time kind of stands alone. It's not going to be hanging out in the American system or the metric system, because really this is the only thing that everyone kind of agrees on, right? Everybody's got hours, minutes, seconds, days. I just put some examples on this, but you could also do, you could multiply. You could say 1 week is 7 days. You could say 1 year is 365 days. Or you could say it's 52 weeks, which is messier. Actually, the whole thing gets messier when you jump up to a year. But yeah. So we only have a couple of examples. Now, if you guys don't mind, this is probably also going to be a shorter class, because, you know, I got enough stuff to pull out another half hour, but I'm not gonna lie, I am ready to drop. I only started work 14 hours ago. So I got on my bike and I rode 6 miles there 15 hours ago. And yeah, I'm kind of beat. So I'm thinking we're going to save the metric system for next time, which is fine because everything I have left, we literally have 10 slides left for the rest of the class. So we're probably going to cut through all of it pretty quick next time. So number 1 says convert 1 hour and 35 minutes into minutes. That one's pretty easy. And in the case of something like that, well, you're pretty safe to just worry about the one piece. You could say, okay, well, how many minutes are in an hour? Well, 1 hour is 60 minutes. And we can totally get away with this one without, you know, without our usual method, because, well, converting 1 hour to minutes is as simple as saying 60 minutes. So you end up with 95 minutes. Okay, well, let's make it a little bit more interesting. That's way too quick of a problem, right? Let's make it a little more interesting. How many days is that? Terrible question, right? How many days is that? Why would you want to convert minutes to days? I don't know. Maybe you want to fraction out your life and figure out how much of your life you're wasting on movies. It'd be an animated movie, but you know. Okay. Well, you would start at 95 minutes and we'd start stepping our way up, right? We would go back to hours. So 60 minutes is 1 hour. And then you could go from hours to days. So 1 day is 24 hours. That works. It's hideous, but it works. The minutes cancel, the hours cancel, and now we're left with days. Okay. So if I multiply across on top, I get 95, makes sense. On the bottom, you're basically going to have the amount of minutes in a day, 1,440. And let's divide them. So I get 0.001 0, 6, 5, 9, 7, then there's a bunch of twos I'm not worried about. Days. So 6.5% of your day. That's yeah, good enough. Okay. Let's do more. Like more is fun. Convert 8 hours into seconds. So we're stepping down the whole time, which means our denominators are all going to be 1, right? Okay, so I can go from 8 hours, and I can multiply by going from hours to minutes. So 1 hour is 60 minutes. And then I can go from minutes to seconds. 60 seconds per minute. And it's canceled. So you end up with 8 times 60 times 60. 28,800 seconds. So again, if you hate your kid, like you're grounded until you count to 28,800, but you're going to count by seconds. If you do that, you know exactly how long it's going to be sitting. That would probably count as child abuse, right? No, you don't think so? I did look it up, and apparently if you convince your kids that they're living in the matrix, that is considered child abuse.
What?
Because you are lying to them about the nature of the world. You are straight up breaking their brain on purpose. So, you know, mental abuse is a thing. You're not supposed to mentally abuse children, nor are you supposed to duct tape them to the wall for a break. But it's not going to keep me from suggesting it. Okay. So if you work 5 days a week for 4 hours a day, how many minutes have you worked in 1 week and how many seconds? So 5 hours a day or 4 hours a day, 5 days a week. Well, 5 days times 4 hours, that's a total of 20 hours, right? Nice part-time job. That might be on top of a full-time job. Yeah. So we're now looking for minutes and seconds. Okay, well, converting that to minutes is real nice, right? Because you would just go from 1 hour, 60 minutes. Now, for this particular equation, I'm not going to go from minutes to seconds because I'm being asked for each one individually. So I'm going to find this. 20 times 60, 2 times 6 is 12. There's a 0 there, there's a 0 there. So I get 1,200 minutes. So that's one of our answers, but we need seconds as well. So we're just going to do that one as a second problem. So 6 times 12 is 72, with 3 zeros attached. So 72,000 seconds. Isn't that fun? It's totally fun. How do we feel? Are we good? Do we want to squeeze out the metric tonight? Do we want to go home? We're getting nods in person. How about you guys online? And the nods are for going home. But I don't know if that translates. No, it's okay. Well, I think we had 2 hours of math in us tonight. So we're gonna call it good. We'll come back next time. We'll do some review on that stuff. And then we'll have a lot of fun with Desi and Hecta and you know what? I'm not gonna skip any of those. And then we'll have tables. Oh my God, look at all these tables, lots of charts. Love charts. Look at that thing. We're gonna do that thing. It's gonna be great. It's gonna be great. But for now, we're done. Go home. Go home, good. Good, done. Done.
Okay.
Oh, I did try that place.
Did you like it? I know, boss. Well, that's where I'm going right now to get a burrito.
I had a California burrito. It's wonderful. You guys online need good, tasty food. Our new clothes.
And actually, like I said, they're not priced too badly.
Oh, you're good. I know you're here. I checked you off. It's cool. It's cool.
Have a good night.
Have a
But next
wonderful
time,
night, everyone.
Try the Connoisseur fries.
Oh, that's my plan next time is the